So this is what we call a finite function, meaning it begins and ends in a specific area and it does not extend infinitely in any direction. I know that because of these solid endpoints here on the left and the right. So if I were to ask you, what is the absolute maximum, or what is the maximum value of this graph, then you would scan with your eyes the highest part of the graph, which actually happens in two separate locations. So both of these are the maximum, but maximum is only asking how high up you go. So I don't want you to name the point like this, or name the point like this. Because when you name a point like this, which one's the maximum? 8, -8, or +1? So it's important when you're labeling a max that you give the y value. So if I ask you what is the maximum value, you would say the maximum value is 1. Now you would have to elaborate. The maximum value is 1, that's how high it can go, when the x value is -8 or 4. So the answer to the maximum value is 1. The detail behind that is when does it happen? Well, it happens when x is -8. It also happens when x is +4. The same can be done with this minimum value question. The minimum value is how low does the graph go? And again, in this particular graph, it reaches that lowest point in two separate locations. But the minimum is still the same. The minimum is still -6. That's as low as the graph goes. But you can elaborate to say that it happens when the x value is equal to -4 or +8. All right, so far we've covered increasing, decreasing, constant. We've covered minimums and maximums, absolutely and relatively. And now we're going to cover the last parts. All right, now for the very last vocabulary word. It's called a zero. And if you have more than one, then it's called zeros. Now it's pretty obvious because in the vocabulary term is the actual definition. When does the graph touch the x-axis at y equals 0? When does the graph touch the x-axis when y is equal to 0? So zeros are all of the points at which the graph crosses the x-axis. So another name for this is the x-intercept. Now, I'm never going to call it an x-intercept because if I called it that, you would know exactly where to look. So I'm going to call it a 0. But anytime you touch the x-axis, one of your coordinate numbers is going to be 0. And if I touch the x-axis over here at 1, 2, 3, 4, 5, 6, 7, right, so this is this one, and this is that one, you'll notice that the y-coordinate is always 0. So if I look at this wavy function down here, it looks like it crosses the x-axis at 1, 2, 3 locations. At 1, 2, 3 locations. Let's look at this one up here. It looks like this parabola crosses the graph at 1, 2, crosses the x-axis at 2 locations. Now we generally don't list them as ordered pairs, but you certainly could. If you would just like to name the x values, since we know by definition that the y value will be 0, you have to use these fancy braces if you have more than one answer. So what are the zeros? They occur when x is equal to, in this example, -8 and -4. So do you remember when I circled these? So can you write the zeros for this last part? The zeros can be found when x is equal to the following numbers: 0, 2, and 7. right, as indicated or illustrated on the graph. So if it says illustrate on the graph, you simply circle the points that you're referring to. All right, those are all of the vocabulary words for this lesson. And now we're going to put together what we just learned with some old stuff, right? Domain and range. And now some new things, mins, maxes, and zeros, as well as increasing and decreasing, and even those positive and negative sections. So you've been given a function, which I've already sketched for you to save time. And now what we're going to do is review all of the vocabulary you need to know in regards to functions. So the domain is how far left and how far right your graph stretches. In this case, it goes infinitely to the left and infinitely to the right. So we can call that all reals, right? All real numbers. We can call it negative infinity to positive infinity, or we can even use interval notation. Negative infinity, less than x, less than positive infinity. You don't have to write all three of these, but the most common would be this one. All real numbers. All right, now for the range. The range is how high up and how low down do you go. So it looks like we have a limit on our down part here, our minimum value, but it looks like we can go up as high as we'd like. So in this case, I'm going to say that the lowest value is -1, -2, -3, -4. But anything higher than -4 is included. So instead of giving an interval like this, -4 to infinity, which is correct, you can also write that in inequality notation very simply by just stating one inequality, like this. Y can be any number as long as it's -4 or greater than that. All right, let's take a look at one of our new words here. The minimum or maximum. You can't have both, typically. You can, but not in a quadratic. Quadratic only has one. This one happens to have a low point. So we're going to identify it as a min. And you have to identify it. You have to say the min. You can't just name a point and not identify it as a minimum or a maximum. So again, the minimum is your y value. So -1, -2, -3, -4. So our min is -4 when x equals 1, 2. When x is equal to 2. Again, I identify the min, but I describe it by using the detail of the x value. All right, how about the zeros? Anywhere does it have an x-intercept? Yep, right here and right there. So the zeros are listed with an x and an equal sign and these fancy braces. And you list only the x value, since to be a zero, your y has to be equal to 0. So those x values are x and 4. All right, when you're scanning your graph from left to right, and your eyeballs are following the graph, at what point are your eyeballs increasing, right? So an increasing interval would be when the graph is moving in an upward direction, which would be from here to there. So the interval would be from here, infinitely. I can't even draw a line over there because it can keep going. So it looks like I start at 2, and anything greater than that is an increasing interval. You could also list it like this, from 2 to infinity. So then the opposite must be the decreasing interval. So the opposite would be this part here, but then as soon as I hit 2, I stop. So it looks like the decreasing interval is anything lower than x is 2. So anything lower than x is 2, it would be decreasing. All right, now for the latest vocab words, the positive intervals, anything above the x-axis, and the negative intervals, anything below the x-axis. So the positive interval happens, let's see, here and here, right? So anything in this zone, anything in this zone is all going to be a positive part of the graph. Positive part of the graph. So what part of the graph are we looking at? Well, anything less than x is 0, or, not and, or anything when x is greater than 4, right? So this is 4. So 4 and up, 0 and down. All right, that must mean the negative interval is only this zone right here. This zone right here is the negative zone. And similarly, it starts at 0 and ends at 4. But it's inclusive, which means it's in between those two values. So we're going to write 0 is less than x is less than 4. All right, that concludes our lesson on all of the characteristics of functions. I'm going to give you a worksheet in which you can take a look at some of these other examples, and you can identify all of these vocabulary words.